we have a fairly complicated rational function that we're going to draw here. And you see there's a number of features that we're familiar with, vertical asymptotes and x-intercepts, but we've also got exponents that are making this a little more complicated than usual. So let's start off with the intercepts. I always like talking about those first. See, we only have one x-intercept to deal with here. It's this factor on top. I don't care about the negative sign. I don't really care about the squared so much when determining the location. What's inside the parentheses is what counts. So you see the x-intercept for this one, if you were to say x plus 5 equals 0, you just get negative 5 comma 0. That's the location of that intercept. Now, that squared certainly does matter, right? We're going to see that affect our behavior, but let's move on for the moment and just get our x-intercept there at negative 5 comma 0. The y-intercept is so easy. You know how this works. We just set x equal to 0, right? That tells us where on the y-axis the function is going to hit it, right? The intercept point. So when you set x equal to 0, look what happens. This goes to 0, right? This goes to 0. So many of these things just disappear. And what's left is your y-intercept. So my x value on that point is 0, and the y value is negative 25 over 10, okay, the leftovers. Now, yeah, we should probably reduce that. Okay, so let's call this, instead of negative 25 over 10, I think negative 5 halves looks a little better. So now we're coming around to the vertical asymptotes. And remember, these are factors which are on the bottom, which are not repeated on the top. Okay? In other words, I see no x plus 2 on the top. I see no x minus 1 on the top. That tells us we have two vertical asymptotes. One of them is at x equals 1. The other is at x equals negative 2 from those factors. And yes, those exponents on them really do matter a lot. We're going to talk about those in a moment too. That affects the behavior of the graph. And then we have our end behavior. Well, the end behavior on this one is very easy. If you look at this function, I've got a power of x squared on the top, power of x cubed on the bottom. That means it is bottom heavy. The factors on the bottom have a greater exponent. Okay, and when you have a bottom heavy function, you always have a horizontal asymptote at y equals 0. No math required. Okay, so there's my end behavior asymptote right there. Well, let's put all these things together in a graph and see if we can make some sense of it. We've got our horizontal asymptote right there. That's nice. Got a vertical asymptote over here at 1. Another vertical asymptote at negative 2. Like about that. That is a nice straight line. How about some intercepts? I've got one at negative 5 way out here. Okay, I'm going to actually need my horizontal asymptote to go a little further just so we can see what's going on way out there. So negative 5 is one of my x-intercepts. I have a y-intercept at, let's see, negative 5 halves. That's about negative 2 1/2, somewhere down here or so. And that's it. That's all the features I have to work with. Now we have to figure out what the shape of the curve is. I'm going to use magenta because I like this one. So I know I have to hit that y-intercept. I'm going to cross it. And the question is, do I go up or down? Well, if I were to go up, see, the problem there is that I'm creating a new x-intercept. Okay? Not supposed to be there. So that means we're not supposed to go up because of the lack of an x-intercept. So let's just take this thing down like that. And same reasoning on the other side. I can't go up where there's not supposed to be an x-intercept. So we're going to head down with this guy. So there's the central portion of this curve. Now over on the other side, I know I've got an x-intercept over here, but I don't know if I'm going down like this or maybe in the other direction, right? Up like that. So let's see if we can use our vertical asymptotes to make some sense of this. If you look at the the vertical asymptote for this guy, this is x plus 2, okay? That is an odd function, or an odd factor right there. And that means this intercept right here has to be odd also, which means we're going to be, well, whereas this side is down right here, see that's down, that means it has to be up on this side. They can't be on the same side of the y direction of that asymptote. They have to be flipped. So an odd asymptote looks like this, where it's down on one side, it's up on the other. Okay, so I'm coming down like that. And I've got an x-intercept here. That's kind of interesting. So I'm going to have to hit that x-intercept. And the question is, what happens there? Do I cross it like this? Or do I bounce off of it like this? Well, again, we're going to look back to the factor that created this thing. And if you look at this factor right here, this factor is even. And if you remember how even intercepts work, those are bouncers. Okay, so this thing's actually going to be bouncing back up like this. But because in the end I have to eventually approach that asymptote, that was not a well-drawn graph. Let's see if I can do a little better here. I'm just going to move this whole thing. So what this thing's going to look like is I come down here, I hit the asymptote, I bounce up, and I don't need to go far up, I just need to go up again, and then it's going to eventually approach the horizontal asymptote. So that's kind of funny looking there. It's got this little wiggle to it. And then I want to talk about the right side of this graph and what's going on over there. So let me get some space up here, and we'll track down this asymptote right here. So this asymptote is even. And the reason I say that's even is because I'm looking at the factor that produced it, x minus 1. And do you see that squared? That's an even exponent, so it means we have even asymptotic behavior, which means I've got symmetry now. And here's what I mean by even symmetry. See how they're both on the same side of the y-axis? These are down and down. That's what even asymptotes look like. So whereas it's down on one side, it has to be down on the other right there. Okay, so that's what the asymptotes produce in this function, and this is the eventual shape of the curve. So let me clean this up and get a sense of what it looks like without all the writing all over it. Okay, so this is what this thing looks like.